And this begins EE 544 on Tuesday, March 4th, 2014.
Can I have the overhead, please? Thank you, sir. Oh, sorry. No, the overhead. No. No. The overhead. This one. Huh? What's the problem? Yeah. Okay. He needs to adjust his camera. Yes, thank you very much. Okay, good. Thank you very much. Good afternoon, everybody. And again, one final reminder, we are going to have our midterm on Friday, March 7th, this coming Friday, March 7th. And it is in Salvatore 101, which is the computer science building, the first floor. And again, as I told you, you have an option of taking it from 4 to 6 or what, 6 to 8. Just curiosity, how many of you are planning to take it in 4 to 6? Okay, good. And the 6 to 8, of course, is there. But you have a choice. Yes? The only thing that I need you to keep in mind, that if you opted for the 4 to 6, you cannot leave early, even if your life depended on it. Do you understand that? You cannot leave early. You have to stay till 6 o'clock before the second batch comes in. Clear? Keep that in mind. Okay, good. Now, the material included will be what? Up to and including today's lecture. I will definitely give you problems on today's lecture. No question about it. Clear? So make sure that you do follow me clearly. Okay. Now, we started talking about the transmission line, and we said that the problem with the transmission line is that we cannot use what? Remember, when you want to use the Kirchhoff's voltage law and the Kirchhoff's current law, you need to make sure that it's valid if the components of the circuits are much smaller than the wavelength. But in RF, when you deal with RF, the lambda is very what? Is very small, which means chances are the components, the physical dimensions of the component, whether they are resistance or capacitor or inductor, is much higher than what? Than the lambda, which means what? We need to deal with it in a distributed fashion, rather than a what? A lump fashion. Now, to overcome this problem, we said we are going to take a what? An infinitesimal section of the transmission line. A very small section of what? Transmission line. Which means what? The components are very what? Small. Because I'm looking at what? As a small section of the transmission line. These sections of the transmission line are represented by this thing here. And we were able to apply Kirchhoff's voltage law and Kirchhoff's current law. Clear? Oh. Now I'm going to abandon the charts, as some of it are not clear and stuff. I don't want you to write anything. You just download it from the web. Just listen to me and try to absorb it. This is what we started last time. Okay, so this is a what? This is I mean, you know, a small version or a smaller section of what? Of the transmission line. It's the length is just what? Delta X. And in a minute we will let delta X approaches what? Approaches 0. Clear? Which means what? It's an infinitesimal region. All the components, series resistor, again, this is because of what? The conductivity. This is what? The self-induction. This is what? Is because of the plates. There is a capacitance between the two wires. And this is what? This is a measure of the dielectric between the two wires. Clear? All of them are units is in what? And for example, this one is what? Is ohm per unit what? Length. For example, ohm per what? Per meter. Did you get this or not? Such that the whole thing is just what? Ohm. This is V of X at time t. This is V of X plus delta X at the same time. At the same time t. We went through this analysis, the Kirchhoff's voltage law and the Kirchhoff's current law, and we ended up with a very interesting equation. The interesting equation is this one here. D square V of x dx square minus this term V of x equal to 0. This differential equation is of the what? Second order. We already know from calculus how we solve, or from differential equation classes how to solve differential equations of order second. Now, first of all, we denoted this term, R plus J omega L times G plus J omega C, square root, we denoted by what? By gamma, which means what? Without the square root, what is this? Gamma square. Now, you can see clearly that gamma is a what? Is in general complex, which means that you can write it in terms of what? In terms of real plus the what? Imaginary. This is called the gamma, it's called the propagation constant. This one is called the attenuation constant. This one is called the what? The phase constant. Always remember that when you are going to be what? Transmitting, there will be what? Attenuation, there will be what? Phase distortion. Clear? Now, in a minute, what am I going to assume? I'm going to assume that alpha is what? Is equal to 0, which means I'm going to assume that the system is what? Sorry, the transmission line is what? Is lossless. Lossless, what does that mean? Before we get into the detail, what does it mean? It means that the power generated by the what? The generator, the power generated by the generator or the power transmitted will be the same as what? The power delivered to the what? To the load. Clear? However, it is not as simple as the way we talk about power generated, power transmitted, because in here we are going to be suffering what? From reflections, which I'll show you that in just a second. So in here, what are we going to talk about in a minute? We are going to talk about the incident power, the reflected power, and the transmitted power. Yes? Which one is the largest of these three? The incident power. The incident power minus the reflected power is the what? Is the transmitted power. Which power I am interested in? In the transmitted power, because that is the power delivered to the what? To the load. Did you get this or not? Yes or no? I will show you the detail in just a second in such a way that it will be very clear to you. You can solve any problem. Okay, let's see if you can help me. So we ended up with what? Solution to this equation, to this differential equation, and the solution was of the form of the following. Vx equal to what? V0 plus e to the minus gamma x plus V0 minus e to the gamma x. What do we see? We see that the voltage at any point on the line, is the combination of what? Two components. One of them is the incident component in the direction of positive x. The other one is in the direction of the what? Of the negative x. Clear? What are these V0 plus V0 minus? This V0 plus V0 minus are the what? Are the one that you will obtain from initial conditions. The thing that I need, I'm not going to give you initial conditions here also. I want you to understand one thing, is that we do not have access to what? V0 plus and V0 minus. Do you understand what do I mean by when we don't have access? We cannot measure it. I cannot bring a what? A voltmeter. Are you following me or not? I cannot measure a voltmeter. I just measure the voltage. What I'm measuring is what? Is V of x. That I can measure. These I cannot measure. Which means what? As we will get to the power calculation, whenever you have the V0 plus and the V0 minus, I need to what? Get rid of them. I need to get rid of them because they are not accessible. Clear? Okay, keep that in mind. We'll get to it shortly. Okay. Now, if we differentiate equation 7 with respect to what? X, and substitute in equation what? In equation 3, I get these equations, and I define the third parameter, which is what? Z0, and we call the Z0 the characteristic impedance. Is this a real impedance or not a real impedance? By real impedance, I mean what? It's you go to the lab, you don't go to the lab. Are you following me or not? You don't go to the lab. This is a characteristic impedance based on what? Based on the components of the that makes up the transmission line. Clear? By looking at Vx and Ix, I can find a relationship between them. I0 plus equal to what? V0 plus over Z naught. I0 minus equal to what? Minus V0 minus over Z naught. Clear? Why is it minus? Why is it minus? It's because it's in the other direction. Clear? Okay. All of these, by the way, equations, I want you to bring it with you in the 8 by 11, but you need to squeeze it. I don't want you to bring what? 15 pages. Did you understand what I just said or not? Squeeze it. Write it in what? Chinese. I don't care how you write it. Did you get my point or not? I'd say you need to squeeze it. If there are some equations which are not essential, you don't need to write it. But the equations that are essential, you need to write it. If in the midterm you tell me I don't have this equation, I will tell you what? Derive it. That's up to you. Clear? Okay, so make sure you understand that. This is Z0, the definition of Z0. Now, but since I'm going to assume that the transmission line is is lossless, then it means what? R equal to what? Equal to G equal to what? 0. By the way, how come I did not say L and C? L and C are what? Reactive components. They are not going to what? They are not going to cause losses. Clear? So I ended up with Z0 equal to what? Square root of L over what? C. Z0 is a real number. I refer it's a real number, even though I'm designating it by Z, but it is what? It is not a real impedance. It's not a complex number. It's a what? Real number. Most of the time, Z0 equal to what? 50. However, in the midterm, you go by whatever I tell you. So if I give you Z0 equal to what? 70, I don't want you to tell me, no, I will make it 50. I will tell you what? No, I will give you 0. Did you understand that or not? As you play by whatever is given in the problem. Okay. Now, let's try to understand by the way, once you substitute Z0, what do you get? What is this equation? Notice, by the way, the gamma became what? Beta. Did you understand? I'm sorry. Gamma became what? J beta, not beta. J beta. Clear? Okay. This is the equation. What is this and this? Can you tell me what is V of X? V of X is the voltage on the line at any point. Is it the same or is it different? In other words, if you change X, will you get the same value or different value? You will get different value. Do you understand what I just said or not? Yes or no? So whatever the value, whatever the question, if the question tells you find the voltage in the middle of the transmission line, then you plug in what? You plug in X by what? L, whatever L is divided by what? By 2. Did you get my point? No response. Did you get my point? Okay, good. Now, so let's look at what? Termination, first of all, which means what? I am not looking at the source. When I'm not looking at the source, what am I assuming? I am assuming that the transmission line is matched to the what? Source. What does that mean? The word, the transmission line is matched to the source. We will get to it in a minute. Did you get my point or not? We'll get to it in a minute. Let's concentrate on the load. This is the load, which is ZL. Is it equal to Z0? In this example, is it equal to Z0? It's not equal to Z0. If it is equal to Z0, then what do I say? I say the load is matched to the line. Did you understand that or not? The load is matched to the line. What does that mean? It means there is no reflection on the load side. Clear? Is it possible that there will be a reflection on the generator side or on the source side? Is it possible? It is possible. But on the load line, on the load side, it is not. There won't be any reflection. Clear? I'm going to assume that ZL does not equal to Z0 to see what we can get out of it. Okay. So now what do I have? The voltage on the load is what? Is V. Now in here also I'm going to change the notation. What is the notation? Instead of starting the labeling of the x-axis here and moving this way, I'm going to label it what? Here and move what? That way. Did you get this or not? So this one is x equal to 0. When you go this way, it's a negative x. Did you get this or not? Always it's easier to make what? To make the load as the reference point. Did you get my point or not? No response. Yes or no? Okay. Let me know if I'm going fast. Am I going fast? No, I'm not going fast. All of this, by the way, we did last time. This is a quick review. So ZL is what? V of 0. Is this, by the way, is this, can I access this? V of 0. Can I have access to it? At the load. Can I measure it? Of course I can measure it. Clear? It is this one that I don't have access to. Did you get my point or not? Okay, good. So V of 0 divided by what? I of 0. I go to the B of X. In place of X, I put what? 0. In place of I put a 0. And this is the equation I get. Clear? Yes or no? Okay. Now, what is V0 minus? V0, from this equation, I find V0 minus in terms of what? V0 plus. And then, what do I define? I define the voltage reflection coefficient at the load. The voltage reflection coefficient at the load is what? V0 minus divided by what? V0 plus. That's a definition. Yes? But that's a useless definition. Why is it a useless definition? One more time. Because I have no access to what? V0 minus and what? V0 plus. So this is just a definition. Now, which one is the useful definition? It's this one. So from here, I divide by what? V0 plus, I get what? ZL minus Z0 divided by what? ZL over Z. ZL plus Z0. Clear? Question. Can this one be in general? In general, is this real or complex? In general, this is complex, which means what? You can designate it by a magnitude and a what? Phase. Clear? Question number 2. Could it be negative? Could this one be negative? Yes. Why? The answer is that, most definitely it could be negative. When? When ZL is what? Less than Z0. Yes or no? In other words, is it possible that Z0 is 50 and the load is 10? Is it possible or not possible? It's possible. Are you following me or not? Okay, so the gamma is what? This gamma could be negative. When we get, which is in about 20 minutes from now, when we get to the power calculation, we will see gamma as is will not appear in its form. It will appear as a what? Absolute value. Did you understand what I just said or not? It will not appear by itself. It will appear in the middle, inside a what? An absolute value. So if it is negative, when you take the absolute value, it becomes what? It becomes positive. Did you understand that or not? We don't have such a thing as what? Negative power. Clear? Okay, good. Let's continue. So this is the definition. What do we deduce from here? If ZL happens to be the same as what? Z0. If ZL happens to be the same as Z0, then we say that the reflection is equal to what? 0. And if the reflection is equal to 0, what does it tell you? V0 minus is equal to what? 0. Which means the voltage becomes only what? The voltage becomes only this one. Which is what? Which is what? Where is it? Which is what? Which is V0 plus. Did you get my point or not? Because this term will be equal to what? Will be equal to 0. Clear? Yes or no? Okay, good. And if ZL is equal to Z0, we say that the load is matched to the what? To the line. We'll get to in a minute what do I mean by saying the load is matched to the source in a minute. Okay, now on the line. Now let's get back to the equation of the line. Where is the equation of the voltage? So there's the equation. V of X is equal to what? V0. What did I do here? E to the minus JBX, e to the minus JBX, instead of V0 minus, what did I plug? Gamma L times what? V0 plus. Because the V0 minus is what? Gamma L times what? V0 plus. Yes? So I write it this way. And the same thing with the current. So now everything is in terms of what? V0 plus. The V0 minus is what? Is gone. Clear? Okay, good. Now, from these two equations, you can see very clearly. 1 second. I'm already in equation 17? Jeez. Maybe you should get a 3, 8 by 11. No, 3 by 11 will be too much. 2 by 11 is fine. Both sides, both sides. Okay. What do we see here? We see that the voltage and the current consists of what? 2 components. One of them we call it what? The incident, and the other one we will call it the what? The reflected. Now, in a minute, when we get to the power calculation, we will see just like the what? The voltage and the current have 2 components, so will the what? The power. Did you get this or not? Yes or no? We will see in a minute. When we get to the power, you will see that we do have a term, which is what? That's the average power. That is the power delivered to the load. Will have 2 components. One of them is the incident power. The other one is the what? Is the reflected power. Did you get this or not? And one more time, which one is the largest of these three? The incident power is the highest. The reflected power is going to subtract from it to get me the transmitted power. I will show you that in just a second. Okay. Now, a couple of parameters that we introduced last time, this is a quick review from last time, is the return loss, which is what? Minus 20 log absolute value of gamma L. And the other one is what? The other one is what we refer to as what? The voltage, the voltage source, the voltage standing wave ratio, the voltage standing wave ratio, which is what? Which is 1 plus absolute value of gamma L, 1 minus the what? Absolute value of gamma L. That tells you what? It tells you that it is the maximum value of Vx divided by what? The minimum value of what? VL. Clear? Clear? What is the range of VSWR? The range of VSWR is what? From 1 to infinity. The smaller it is, the better or the worse? The better it is. The better means what? Means that the load is pretty much what? Matched to the what? To the line. Did you get this or not? If you get VSWR to be high, it means what? It means that the reflection is so what? It's so high. Clear? No response. Clear? Okay, good. I don't want you to forget this. They ask in the interviews for possible entry positions for RF. They ask a lot on what? On the VSWR. Clear? They expect you to know that. Okay, so I don't want you to forget these things. Now, keep in mind that the way to find this is to write from equation 17, which is this one, which is this equation, you find the what? The absolute value. Now, notice I need to explain to you where did this come from, the 2 here. I factored out this one outside. Yes? What remains inside? 1 plus what? Gamma L e to the what? J to beta x. Yes? And then when I took the absolute value, the e to the minus j beta x that I factored from here, it's just simply what? It's just simply 1. So I ended up with this, and then what? I replaced gamma by what? Absolute value of gamma L times what? E to the j theta. Theta is the phase angle of what? Gamma L. And you see that this one will be maximum when this term is equal to what? Is equal to multiple of what? 2 pi. Yes or no? Okay, and it will be minimum if this one is a what? Is an odd multiple of what? Of pi. Pi, 2, 3 pi, 4, 5 pi, and so on and so forth. All of these things. Clear? Clear? Okay, sometimes the question tells you what? It tells you the first minimum is at a distance of this. Did you get this or not? Why do they say the first minimum? Why do they say the first minimum? Is it possible that you do have multiple minimums? That's why we call it what? A standing wave ratio. It's sinusoidal stuff. Did you get this or not? Okay, good. Any question on this so far? Okay, good. Let's move on. Now, the reflection coefficient can be calculated at any point on the line. At any point on the line. What do I have? For example, when x equal to what? Minus L. What do I get? I get gamma of minus L. What is it equal to? V naught. Did you answer where this came from? Where this came from? V naught minus e to the minus j beta L. V naught plus e to the j beta L. I am looking at what? I am looking at this equation with x equal to what? Minus L. Did you get this or not? And you put it together. Why am I emphasizing this equation? I am emphasizing this equation to tell you is that if you take the absolute value of the reflection, it will be what? The same whether you are looking at where? At the load, or whether you are what? You are measuring the reflection at any point on the line. Did you get this or not? Yes or no? I'm going to say a statement. See, tell me if it is true or false. The reflection coefficient is the same at any point on the line. True or false? Definitely false. The magnitude of the reflection coefficient. The magnitude of the reflection coefficient. Is it the same? It is the same. The magnitude, not the reflection coefficient. Reflection coefficient is what? Is in general complex, which means it has a magnitude and a what? And a phase. Clear? Okay, good. Now, in the midterm, you will see some problems which are what? True and false. I will tell you what. If it is false, you need to tell me the reason. But if it is true, no, you don't need to tell me a reason. You just say that it's true. Clear? I don't want you to guess. So if the answer is false, but your reason is what? Is wrong, or you don't write any reason, I will not give you credit for it. You need to make sure that you can answer. Clear so far? Okay. By the way, soon we will get to the most important part, which is what? The power measurement, the power calculation. In about 10 minutes. I said a moment ago in about 20 minutes, and I'm still there. So, but we'll get to it in a minute. Okay, let's look at what the impedance stuff. Input impedance. Input impedance is the impedance that you look at what? At the input of the line. Question. Can you measure the input impedance at any point on the line? At any point on the line, not necessarily this. Okay, so in other words, let me ask you a question. This is a premature question, but let me ask you a question. I have a transmission line. There is a load. Yes, and in here, I have a what? Another transmission line. This one, we will refer to it as a stub. Did you get my point or not? Okay, let's assume it's open circuit. Just an example, open loaded or what? Short circuit, doesn't matter. And then I have what? I have another transmission line. Yes? Answer me the following question. What is the load of this guy? What is the load of this transmission line? I need to find the what? The input impedance of this stub. Yes? And the input impedance of what? This transmission line, and connect them in what? In parallel. Did you get my point or not? Yes or no? This stub could be put, by the way, let me show you another scenario. This is a transmission line, and this one here is a stub. Open circuit. Let's assume it's open circuit. Just an example. Can you find me the impedance looking in here? The impedance looking at here. What do? You take the input impedance of the what? Of the stub. Yes or no? In parallel with what? With the impedance looking between those two at a given what? L prime. Did you get my point or not? L prime, the whole length is what? From here to here? Sorry. From here to here is how much? L. But you are looking only at L prime, which means what? In this equation, you are going to substitute what? L prime. Clear? You can find that at any point on the line. Did you get this or not? Okay, good. Now, let's get back. Looking into the line, that's the input impedance. And again, as I told you, we started x equal to 0, which means what? This is x equal to what? Minus L. So I substitute B of minus L divided by what? I of minus L. Clear? And I ended up with what? Zn equal to what? Z naught plus this. Again, where did this came from? It came from equation 17. You follow me or not? By putting what? X equal to minus L, x equal to minus L, and dividing this by this, you get this. Did you get where the minus 2 beta L came from? This minus 2. Did you understand that? If you, again, factor this one out, it will cancel together. Clear? Okay. This equation, you use it if the question gives you the what? With the question, a question, true or false? True or false? Question. The input impedance is a function. The input impedance is a function of the length of the line and the characteristic impedance only. True or false? Why? What is the other parameter that it say that again? That's the, okay, so I forgot about gamma. I'm sorry. One more time. I'm going to repeat the question. One more time. I'm sorry. The input impedance is a function of the load, the characteristic impedance, and the length of the line. True or false? Silence. Silence of the lamps. What is it? There is another parameter here. Does it depend on the frequency? Where? Where? Do you see F in here? You see F in here. Beta is equal to what? 2 pi over what? Lambda, and the lambda is what? Is C over F. Did you get my point or not? So don't jump right away to conclusion that the input impedance does not depend on the frequency. Of course it depends. Did you get this or not? Okay, good. Now, you write it this way here, and then you what? Replace the gamma. This gamma, by the way, it should be what? Gamma L. I'm sorry, gamma L. Did we designate it before gamma L? Yes, gamma L. So this is gamma L. Gamma L. Clear? Okay. We replace gamma L by what? By the equation. What is gamma L? By this equation. ZL minus Z naught, ZL plus Z naught, and you end up with an equation which is strictly a function of what? A function of the characteristic impedance, the load impedance, the length of the line, and the frequency of operation. Clear? No response. Clear? Okay, good. Now, so you get this. Now, listen to me. If lambda is equal to what? Not lambda, sorry. If L is equal to what? Lambda over 2, which means what? This is a 1/2 wavelength transmission line. Then what do I have? This is Zn is equal to what? ZL. What does Zn equal to ZL means? When I say the input impedance is the same as the load, what does it mean? It means that as if I am removing the what? The transmission line totally. Did you get this or not? And I'm putting the ZL as what? As the load to the source. Did you get my point or not? Okay. Now, if L, this is extremely important. There is no question about it that I will sneak it in the midterm somewhere. Did you get my point or not? If the length of the line is a quarter wavelength, then the equation become what? Zn equal to what? Z naught square over what? Over ZL. Clear? Or what? Z naught is equal to what? ZL times what? Zn. Clear? No response. Clear? By the way, what does that tell you? If lambda is equal to, if L is equal to lambda over 4, what does it tell you? It tells you that the product has to be what? Real. Do you agree with me or not? Yes or no? What does that mean? If ZL happens to be complex, what can you tell me about Zn? The square root has to be what? This has to be real. Did you get this or not? So if ZL is complex, if ZL happens to be what? Complex, let's say 5 plus what? J2. Yes? What does that tell you about Zn? So that what? So that the complex part goes away. Did you get my point or not? There should not be any complex in here. Clear? Okay, good. Now, a special case. What is a special case? If you short circuit the load means what? Means you put a short circuit here. Did you get this or not? What does it mean? In this equation, ZL equal to what? 0. So this is 0, this is 0 gone, and you end up with what? What do you end up with? 0 divided by 0 is what? It's gone, so you end up with what? Gn equal to what? J, Z naught, tangent, beta L. Inductive or capacitive? Or does it depend on L? It depends on what? Depends on L, a beta L. If beta L is between 0 and pi over 2, then this one is what? Is inductive. Why? Because the tangent will be in what? The angle will be in the first quadrant. And vice versa between what? 0 and 4. And I showed you last time. Where is it? Show you. I showed you the characteristic of it. This is the loss last time. You see this? I'm sketching the impedance here. You see this? Okay. Do you understand what this is? 0.1, 0.2. This one is what? 0.25, which means what? Lambda over what? 4. Everything is scaled by lambda. This one is behaving as a what? As an inductor. In here, what is it behaving as? Capacitor. In here, inductor. In here, capacitor. Did you get this or not? No response. Did you get it or not? Okay, good. Now, the same thing, by the way, applied for what? For the open circuit load. Open circuit load, what does it mean? It means ZL is equal to what? Infinity. Yes? If ZL is equal to infinity, this term and this term are what? Negligible. So I end up with what? ZL divided by ZL is what? Cancels out. And I end up with what? Minus J0 cotangent of what? Beta L. Clear? Make sure, by the way, in your calculator, don't bring a calculator from a serial box. Just addition and subtraction. Make sure that it has a what? Logarithm, and make sure that it has a what? Trigonometry and all of these fancy functions. Clear? No response. Clear? Okay, good. So in this one here, by the way, it's the other way around. So if you look at the impedance here, what do you notice? This is for the open circuit. What do you notice? In here, what is it? Capacitor. In here, what is it? Inductor. In here, what is it? Capacitor. In here, what is it? Inductor. Did you get this or not? Now, what does that tell you? What does that tell you? If you want, suppose you don't have a given inductor or a given what? Capacitor. Can you use a transmission line? You can use a transmission line with a proper length, and the load is either what? Open or what? Short. You can create a what? You can create an inductor, or you can create a what? A capacitor from a transmission line. Clear? No response. Clear? Okay, good. Now, let's look at what? Let's look at the case in which we have both a generator and a what? A load. So far, we have been talking about what? We have been talking about, what have been we talking about? We have been talking about the case in which there is no reflection on the what? On the source side, which means what? The source is, or the generator. What am I using? G. Okay, sometimes I use the source, sometimes I use the generator. I need to be consistent. Since I'm using G, I'm going to use what? The generator stuff. Clear? When the line is matched to the generator, to the source, it will be what? It will be, if it is not matched, there will be a what? A mismatch. Yes or no? Okay, let's see if you can help me. This is now the situation. I need to define a new reflection coefficient. And this is a little bit of a tricky part, so that you need to understand what I'm saying. Where am I looking at this? From which point am I looking at? I'm looking at it in here. Do you follow me or not? Backward. Did you get this or not? What is the gamma G? What is the gamma G equal to? This now is behaving as a what? If I'm looking this way, this one is behaving as a what? As the load. Yes or no? This is going to be what? Short-circuited. Yes, because I'm looking only at impedances. Yes or no? So what do I define? Gamma G, which is what? ZG minus Z naught, ZG plus Z naught. Did you get this or not? Yes or no? Okay, what does that mean? If ZG is equal to Z naught, what do we say? We say the line is matched to the what? To the generator. Are you following me? The line is matched to the generator. Yes? Which means what? Gamma G is equal to what? It's equal to 0. Now remember, gamma L is the definition of gamma L. Gamma L is looking from these two terminals. Did you understand what I just said? Yes or no? Now, before we get to the Zn, this is a little bit of the tricky part here. The Zn. Let me explain to you one thing, what is happening here. Let's assume I have mismatch in both directions. Both directions, which means what? At the source and at the what? At the load. What is going to happen? Listen to this. When this waveform is going to come here, it will be what? Some of it will be what? Reflected. Now, when it comes to here, some of it will be what? Reflected. When it comes to here, some of it will be what? Reflected. How many? How many times? Infinite number of times. Did you understand what I just said? Infinite number of times. You need to look at what? The steady state situation. In the steady state situation, what do I have? I have just what? One transmitted and one what? Reflected. Did you get my point or not? In the steady state. Steady state means what? You take the aggregation of all of these reflections. Clear? No response. Clear? If this one is matched to the source, what does it mean? It means there is no reflection from the source side, but there is a reflection from the what? From the load side. Did you get my point or not? Okay. And I will make this one clear to you in just a second. So if it is not matched, we are going to have infinite sequence of what? Reflections. In the steady state, the net result is one wave traveling into the load and one wave that is reflected to the what? To the generator. Clear? Now, I'm going to introduce right now to you, and you, before we get into the, before we get into this, which is the following. What is this? I want you to tell me now, what is this? Where am I looking at? Where am I looking at here? I'm looking at, in other words, this is the steady state. This is the steady state situation. I am looking at what? The input impedance in here. Did you get this or not? Yes? Okay, and I'm defining it as what? Zn. minus Z naught over what? Zn plus what? Z naught. This is the reflection coefficient looking into the what? Did you get this or not? I need you to understand one thing here, because this one a little bit confusing, and we need it in the calculations of the power in a minute. I want you to understand this equation. This is not the same as this. Do you understand that or not? This one is looking at what? Looking at the line towards who? Towards the source. Whereas this one is looking into the line. Are you following me or not? Into the line at what point? At the input, Zn. But it's looking at toward the line. Did you get my point or not? So this is defined as what? Zn minus Z naught over what? Zn plus what? Z naught. Yes. By the way, once you get into the power calculation, this one will be very clear. In a minute, I will show you this. Clear? But this one, what does it mean? It means as if I am replacing the line by a what? By an impedance whose value is what? Zn. Did you get this or not? I'm replacing the line by a value which is what? Impedance, which is equal to what? Zn, which is the impedance looking at what? Looking at this point. By the way, what is Zn? Can you tell me what is Zn? Just Zn. Not the equation, but what the ratio of the voltage. What voltage? The voltage at this point divided by what? The current. Yes? That voltage, is it V0 plus or is it the total voltage? That's the total voltage. Do you understand that or not? That is the total voltage. Did you get my point or not? I will show you that in just a second if you give me a minute. Question? Yeah, is the gamma L at minus X equal to the gamma N? Is the gamma L at minus X? Let's find the relationship between them. Can you give me a minute to find what is the relationship between gamma L and what? Gamma N. Can you give me a minute? We'll get to it in a minute. Did you understand this? Did you get this or not? Okay, good. Now, let's skip this one here, but let me just write here. The voltage on the line at the generator side is what? Is V of what? Minus L. Yes? Which is equal to what? What is this? Another way of writing it. Vn. This is Vn. Is there a plus or there is no plus? Is this a plus or this is just a real voltage? That's a real voltage. Did you get this or not? This is the Vn. What is it equal to? Vg, which is the volt. By the way, if you replace this transmission line, where is it? If you replace this part by Zn, replace this part by Zn, what will be the voltage at this point? It will be what? A voltage division circuit. Yes? Which is what? Which is V, help me, Vn equal to what? Zn divided by what? Zn plus Zg times what? Vg, which is this one. Zn divided by Zn plus what? Zg. But what is it also equal to? V naught times what? E to the j beta L, e to the gamma, e to the minus j beta L. Question, how come this one became positive? It's because of minus L. I'm substituting minus L. This one becomes positive, this one becomes the negative exponent. Yes? From this equation, what am I going to get rid of? I'm going to get rid of V0 plus. Why? Why do I want to get rid of the V0 plus? Because I don't have access to it. Are you following me on it? I have an access to what? To Vg and so on and so forth. All of these things. Okay. Now, let's skip this set of charts. We'll come to it later on. I want you to understand this in your set. I will post this. This is not from last time. This is today's stuff. I want you to understand the power consideration, and from it, I will get back to your answer, to your question. What was your question? What is the relationship between gamma N and gamma L? Gamma N and gamma L, not gamma N and gamma G. Did you say gamma N, gamma G, or gamma N, gamma L? Those are related. Do you follow me or not? Why? Because both of them are looking on the what? In the same direction. Okay, let's get to this so that you understand what I'm saying. I am interested in what? What is the average power that is being transmitted? Yes? I want you to see this diagram just for a minute. This is, by the way, example from Steer, but his solution is so verbiage. Verbiage means what? A lot of words. I want you to understand to use this method here. It's much easier. Okay. I want you to think about what? There are two boundaries here. This is the boundary at the source. This is the boundary at the load. Don't worry about this. Don't worry about this yet. Clear? Okay. This is the incident power. This is the reflected power. This is the what? The transmitted power. Yes? Which one am I interested in? I'm interested in the transmitted power. Why? Because the line is what? Lossy. Because the line is lossy, then that transmitted power will also be the power delivered to who? To the load. Did you get my point or not? Yes or no? The line is what? Lossy. Which means if I want to look at here, which one will be PT1? Which one? Is it P2 plus or PT2? You lost me here. I can tell you lost me. The line is lossless. This is the only case we are going to be looking. Okay, don't answer this question for me. You lost me here because I jumped. I know when I jump stuff. When my students lose me, it means what? I said the line is lossy? All of you heard this? Is there a witness for the prosecution? No, nobody? Okay, my mistake then. I said lossy. We are not going to discuss lossy lines in this course. Do I need to repeat this or not? So whenever I use the word lossy, it means what? I made a mistake. I want you to understand the definition of the power. How do we measure the power? It's 1/2. Question, where the 1/2 came from? Where is the 1/2? Stop in here for just a second. Where is the 1/2 coming from? This is sinusoidal. I'm looking at what? RMS stuff. Did you understand that or not? 1/2. The real value of V times what? I conjugate. Why? Ohm's law, when he came, Ohm's law, when he told us that the power equal to what? The voltage times the what? The current. He was talking about what? Real loads, real resistances. You follow me or not? When you deal with complex stuff, you need to modify it. It will become what? V I conjugate. Clear? No response. Clear? Okay. Let's see if you can help me. What is V in? This is the crucial thing that I need you to understand. What is V in? V in is V0 plus 1 plus what? Gamma N. This is not gamma G. This is the gamma N that I defined it to you a moment ago. Did you get my point or not? Yes or no? Okay. What is the first term? It's V0 plus. Can you tell me what is the second term? In other words, what is gamma N V0 plus? What did we designate it a moment ago? What did we designate it a moment ago? The gamma V0 plus times gamma N is the what? Is the V0 minus. Did you get my point or not? Yes or no? Okay, that's the reflected. This one is the incident. This is the total voltage. What is this? IN is what? V0 plus Z0, 1 minus gamma N. Why? One more time. Why is it gamma N? I am looking at where? Into the no, not into the load. Into the transmission line. Do you understand? From which side? From the source side. I am not, in other words, I think you lost me here. Did you lose me? One second. Where am I looking at? I'm looking here. This way. Yes? Not this way. Clear? Okay, good. Now, so Vn equal to V0 plus 1 plus gamma N. In equal to what? V0 plus divided by what? Z0, 1 minus gamma N. Did you get my point or not? Yes or no? Okay, good. Now, what do? I take this, and I take this, which is what? What is this? The Vn and the In is these, the V and the I. Yes or no? At what point? At what point? At the input. Yes? I'm going to substitute this with this. What am I getting? Can you tell me? What am I getting? Where? This 1/2 is this 1/2. Yes? Okay. I want you to take the conjugate of this guy. What is the conjugate of this guy? The conjugate of this guy. What is it? Is the conjugate of V0 plus. Yes? Does not apply to this. Why? Because Z0 is what? Is real. Yes? What does this become? Conjugate. Yes or no? So what do I have? 1/2. Do you understand where this came from? The absolute value of V0 plus square. If you multiply x by x conjugate, what do you get? The absolute value of x square. Agree? Did you understand this? How about this? Same. Can you tell me where this came from? Where is this came from? I am multiplying 1 plus gamma n times what? 1 minus gamma n conjugate, and I'm taking the real value. I'm taking the real value. What is the real value of this? What is the real value of this? Is 1 minus the absolute value of gamma n square. What happens to the middle term? Is there a middle term? You lost me here. Huh? No, no, you lost me here. Listen to me. I have 1 minus what? X multiplied by what? Sorry, 1 plus x times what? 1 minus x conjugate. What would I get? I get 1 plus what? X minus what? X conjugate plus. Do you agree? No, sorry, not a plus. I'm sorry. Minus. Do we agree? Is this real? Is this real? How about this? No, this is not real. Yes or no? Is this real? No, it's not real. When you subtract this from this, will there be an imaginary term? There will be an imaginary term. The real part will cancel, but the imaginary term is there. What happened to it? Because I'm taking the what? The real part only. Did you get this or not? Yes or no? Okay, good. So I get this equation. From this equation, I want you to tell me, what do you notice? You notice that the average power at the input, this is the power delivered by who? By the source. Did you get this or not? At the input side. What is it? It consists of two components. This component and this component. Yes or no? What is the P plus? Can you tell me what is the P plus? And first of all, can I measure this power? This one, I cannot measure it. Did you get my point or not? What is it? Tell me, where is this coming from? The first term. That's the incident power. Yes? What is this? Where? What is it? It's the second term, which is what? 1/2 this times what? This. Did you get this or not? Yes or no? So what do we see from these two equations? Sorry, from this equation, what do we notice? Just like the voltage and the current, we were able to write them as the what? Two components, the incident and the what? Reflected. So is the what? So is the power as well. Clear?
Is there a minus sign missing in P and minus?
Where is the P and sign? No, this is a minus sign already. Here? Why? Why? There is a minus sign here already. That's a minus sign. These powers are what? Are positives. Yes or no? Power cannot be negative. Do you understand that or not? That is why when I wrote it at the beginning, you notice what I wrote it? Plus, then I made a boo-boo. I changed it to what? To minus. Clear? Clear? Okay. Now, equation 1 is useless. Why? Why equation 1 is useless? I cannot use it. Why? I don't know what V0 plus is. You follow me or not? So even though this equation gives me what the total average power, but it's useless because I cannot use it. I cannot measure it. Clear? So what do? Let's see if you can help me. What is V0 plus? What is the V0 plus? This is what we saw in here. What is the V0 plus? Equal to Vn divided by what? 1 plus gamma n. Yes or no? So it's what? Vn, 1 plus gamma n. But what is Vn? What is Vn? It's Vg times what? Zn divided by what? Zn plus what? Zg. You are losing me? Are you losing me? Okay. Now, notice, by the way, in this case here, I replaced the line by just a what? An impedance, which happens to be what? The input impedance. Clear? Okay. Then, I want to what? I want to write everything in terms of the gammas. So what do I have? Zn is what? What did I define this a moment ago? Here, from this equation, write Zn in terms of what? Gamma. This is what you get. Did you get this or not? No response. Did you understand what I'm saying? Okay. How about the Zg? Do I do the same thing? Yes or no? Which equation am I using here? Which equation am I using here? Which is looking where? Into the line. Yes or no? Okay, so what do I have? Zg equal to Z naught, 1 plus gamma S, 1 minus gamma. Oh, jeez. This S should be what? But this one is easy to change. Why? Just give it some. Yes? Yes? So it becomes like this. I hope it does not appear again. Oh. Clear so far? Okay. So I'm going to replace every Z and every ZG by what? By what is, I want to put everything in terms of what? In terms of the reflection coefficients. So you end up with this equation. Are you following me or not? Yes or no? Now, I want you to see one thing here. You notice, by the way, everything is what? Magnitude. In here, is this complex? In general. Is this complex? In general. But I am what? I am multiplying first of all, then subtracting from 1, and then taking the what? The absolute value. Did you get this or not? Okay. There is missing here, I forgot, it's lambda G, lambda L. What is lambda N? I want you to tell me what is lambda N equal to in terms of the lambda L. This is now your question. It's equal to what? Lambda L times what? E to the minus J 2 beta L. Did you get this or not? Answer me the following question. Is the magnitude of lambda N, is the magnitude of gamma N the same as the magnitude of gamma L? It's the same, but it's different what? It's different phase. Did you get this or not? Yes or no? Cannot hear you. Okay, so that's the thing that I was just telling you about.
At L equals 0, they will be equal, isn't it?
At L? Of course, at L equal to 0 means what? You are looking at the load. You are looking at the load.
So at L equals 0, is it at the load side or the...
At L equal to 0, which means what? X equal to 0. We are looking at the load. So that's just the load. There is nothing there. Did you get my point or not? Yes? Okay, good. Well, how did I go from here to here? Can you tell me how did I go from here to here? What did I substitute? In the place of the gamma N, I put what? Gamma L e to the minus J2 beta L. Yes? And in the place of the what? Magnitude of gamma N square, I put what? Magnitude of gamma L, the whole thing what? Square. Clear? No response. Clear? This is the most important equation of them all. This is number 6. Notice, by the way, listen to me. If the load, now, so let me write this statement before I go to the different cases. Since the line is what? Lossless. Where was I looking here? Where was I looking here when I calculate the Pn? At the generator. Yes or no? This is called what? What is this one called? The transmitted power, which consists of what? Two components. What is the first component? One more time. The first component is what? The incident power, and the second component is the what? Is the reflected power. Did you get this or not? Yes or no? Then, the difference between them is the what? Is the input power. Yes? The transmitted power. Yes or no? This, by the way, is taking care of what? All the reflections. All the reflections. Because you are using what? Gamma N. Gamma N is what? You are replacing the line by a what? An impedance, which is happen to be Zn. Yes or no? Okay, good. Now, answer me the following question. Since the line is lossless, then the transmitted power is the same as the power delivered to the what? To the load. That is the same. The transmitter line is what? It's lossless. It's not going to provide any losses. Did you get my point or not? Yes or no? Which means the following. Go back to the example prematurely. I will explain to you in detail. Answer me the following question. Do you see this boundary? Do you see this boundary? Tell me. The PT1, what do I call it? The transmitted power. What is the equation for PT1? The PT1. This equation. Did you get my point or not? Is that the same as the PT2? Is that the same as the PT2? Yes, it is. Because the line is what? Is lossy. The power generated is the same as the power delivered. You lost? No, I understand that there is a reflection. You are comparing what? P1, if there is a reflection, P1 0, this P2 0, sorry, PT plus. This P2 plus is the what? Is the incident power. What does this one correspond to? It corresponds to the transmitted power plus any what? Plus any reflection from the generator. Did you get this or not? This is in the steady state we are talking about. Are you following me or not? In other words, can you tell me what is P2 plus equal to? This P2 plus is equal to what? You lost me here. I know that you lost me. Jeez. P2 plus equal to what in this diagram? No. I want you to tell me based on the first boundary. What is the P2 plus equal to? P2 plus will be the same as what? P1 plus. Did you get this or not? P2 plus will not be the same as what? PT1. Do you understand that or not? Because we need to take into account that there will be what? Reflections on this side. Yes or no? Okay, give me a moment. Can you give me a moment? You're still losing me here. Give me a moment. Okay, so since the line is lossless, this is the same power delivered to the what? To the load. Clear? I want you to tell me, before I show you the examples, how is the Pn plus and the Pn minus related? I want you to tell me how it is related. Did you understand these two? Yes? What is the gamma, absolute value of gamma n? Absolute value of gamma n. Is it the same as the absolute value of the gamma L? Which means what? It means that the relationship will be the same as what? At the load as it is there at where? At the generator. Did you get this or not? You are losing me? Are you losing me? Okay, good. Well, I will show you that in just a second in an example. Okay, let's take special cases. Matched load, matched source. Both of them are what? Matched. Which means what? There is no reflection at the load and there is no reflection at the what? Source. Tell me. Do not look at here. Tell me, what do you get from here? What do I substitute? Gamma L equal to what? 0. Gone. Gamma S equal to what? Sorry, gamma G equal to what? Gone. Gamma G equal to what? Gone. Everything is gone with the wind. Are you following me or not? What remains? 1. So what do you get? 1 over 8, the absolute value of VG square divided by what? Z0. Why do I say this is the maximum available power provided by the source? By the way, it's the same also as saying what? What is the maximum power delivered to the what? Load. Why? Because the line is what? Lossless. But why do I say maximum? I say maximum because there is no what? There is no reflection. Did you get my point or not? Yes or no? Okay. I'll give you the example in just a second. The load is matched, but the source is mismatched. Tell me what happens. The load is matched, but the source is what? Mismatched. Tell me what happens. This one equal to what? This one will also be equal to 0. Why? Because the gamma L equal to 0. But will this one be equal to 0? That you need to take it into account. Oops. That you need to take it into account. Did you get this or not? Yes or no? No response. Okay. Now, did you get this? The most important equation is which one? Which equation? I'm pointing my finger to it. Which equation? This or this? Doesn't matter. But this one is the one that you will probably use. Why? Because usually the question gives you the load rather than the what? The input impedance. Did you get my point or not? Yes or no? Okay, let's see. I'm going to show you one. Can you? Yeah, sorry. I'm going to show you one example from what? From Steer, chapter what? 5. This is the new edition. The old edition, if you don't have it, email me and I will tell you what it is. But you can find it in the transmission line. He has 3 or 4 examples. Are you following me or not? He fills like about 5 pages or 4 pages solution of it. Solution should not exceed what? 1 page. If he what? If he recognizes this equation. So I need you to understand it. But I will still like you to read his procedure to see if you feel more comfortable with his procedure. If you do, which means what? He uses Thevenin's equivalent and stuff like that. Actually, you don't need to use any one of these because it's already taken care of here. Let's see if you can help me. This is his problem. Not his problem, sorry. He does not have a problem. This is his example, 510. There's another example afterwards, is what? 511. Which one did I choose? I chose to show you the easier one. So that the harder one, I put it to you. Clear? What do I have here? I have a generator at what? 5 volt with a source impedance of what? 40. Which means what? This is the ZG. Yes? The line, there's a transmission line, which is what? Quarter of a wavelength. Quarter of a wavelength. Yes? No response. Which has a characteristic impedance of what? 40. Yes? Question. Is the line matched, is the line matched to the source? Yes, it does. Yes, it is. Clear? Okay, now concentrate. Then there is another line which happens to be of infinite length. Question. If it is an infinite length, does it matter whether the load is short-circuited or open-circuited? Does it matter? Doesn't matter. I don't care about what's going on in here. What am I going to see in here is the same as the what? The characteristic impedance, which is, happens to be what? 100. Did you understand what I just said or not? So if the question in the midterm give you that the line is of infinite length, which is something which is what? Not practical. And in practice, do we have infinite length? We don't have infinite length. I did just on a piece of paper. If the question tells you that the line is of infinite length, it means that you can replace the line by a what? Its characteristic impedance. So what did I do? I replaced it by ZL100. And what did I discover? I discover there is a mismatch at where? At the load. Did you get this or not? There is a mismatch at the load. Now, let's see if you can help me. What is the gamma L? By definition, what is the gamma L? ZL minus Z naught divided by what? ZL plus Z naught. What is the ZL? 100 minus 40 divided by what? 140. What do I get? 3/7. Yes or no? Now, I want you to show you, before we get to this, I want you to show you this relationship. Do you see this relationship? What does this relationship tell you? It tells you that the gamma N magnitude is the same as the magnitude of what? Gamma L, but it's a different what? Phase. Let's see. What is the Zn? This is a quarter wavelength transmission line. A quarter wavelength transmission line. Yes? What is the Zn? We already got to the equation, which is what? Zn equal to what? Z naught square over what? So what is it? Z square 01, which is the 40, times 40 divided by what? 100, which is what? 16 ohm. Clear? Yes? What is the gamma n? Gamma n, remember, what is the gamma n? Gamma n is the reflection at where? Looking into the line. From where? From the source. Looking into the line. Not into the source, into the line. Okay, so what do I have? Zn minus Z naught, Zn plus Z naught. What do I end up with? Minus 37. Do they have the same magnitude? They have the same magnitude, but they don't have the same what? Phase. Why? Because the L was what? Lambda over what? Over 4. This one is what? 2 pi over lambda. Help me. 2 pi over what? Lambda. And this one is what? Lambda over what? 4. So you get what? E to the minus. Did I mess up?
Yeah, J pi.
J pi. Yes? Which is what? What is e to the minus J pi? Come on, come on. E to the minus J pi is what? Is cosine of what? Pi. Which is what? Minus what? That's explained this. Minus what? Did you get it? Yes or no? Okay, good. Now, again, note that the absolute value of gamma n is the same as the absolute value of gamma L. What is gamma G? Why? It's matched. The second example, by the way, the second example that he shows, he put what? In a place of 40, he put what? 30. You follow me or not? I want you to do this example without reading his solution. I want you to feel comfortable using this equation. Which equation? This equation. This or this, doesn't matter. Did you get my point or not? This is the best thing to do. Do not read his solution first. Use this equation and see if you get the same what? Answers that he is getting. But he is filling like 3-4 pages or something. Here it's just one equation. Clear? Okay. Now, so what is it? Gamma G equal to what? 0. So what do? I plug in which equation? Equation 6. What am I going to plug in gamma G? 0. Gamma G, which means what? This one is 1 over 1. Yes? But this one I cannot neglect. So what do I get? 1 minus, did you understand the 9 over 49? Where did this came from? 9 over 49 is 3 pi 7 square. Clear? What do I get? Help me. What do I get? 63.8 milliwatt. What is this one more time in this diagram? Can you tell me what is this that we just calculated? The 63.8. What is it? PT1, which is also equal to what? PT2. This is very hard to say. T2, 2T, T2. Did you understand what I just said? Cannot hear you. Okay. Can you explain to me where did this come from? Which is PI plus? Why is it 1/825 over 40? Why? Do we see two components here? One of them is the what? Is the incident power. The other one is the what? The reflected power. What is the equation for the reflected power? In this example, it's 1/8 VG, absolute value of VG square, divided by what? Z naught times what? Absolute value of gamma n square. But the absolute value of gamma n square is the same as the absolute value of what? Gamma L square. Did you get this or not? Yes or no? What is this in this diagram? In this diagram, what is this? 78.13. Can you show it to me? P1 plus. What is it also equal to? P2 plus. Did you get this or not? What is this? 14.33 milliwatt. What is that? That's this one. Yes or no? Is it the same as this one? That's the same as this one. What is this? 63.8. This, and it's the same as the power delivered to the what? To the load. Clear? Clear? This will be in the midterm. Clear? Okay, but in the midterm, what am I going to give you is what? I'm going to give you a combination of mismatches in the load and in the source, like example, the other example of steer, so that I need to make sure that you know how to find what? How to use this equation. This, either equation 5 or equation 6 is the crucial one. Did you get my point on that? Yes or no? Okay, good.
Professor,
That's about it for the transmission line. You can read the charts on your own. Now, but I want just to go back a little bit to the impedance matching. To the impedance matching. Remember I told you we can use the transmission line as an impedance matching circuit? Okay, so let's see a little bit on that. This is what I have. This is ZL. Yes? And I want to match it what? Transmission line. I want to match it to what? ZS. Yes? Okay, what does it mean? It means I want the impedance looking in here to be equal to what? No, ZS conjugate. Keep that in mind. When we say match, it means what? Zn equal to what? ZS plus. Did you get this? Sorry, not ZS plus. ZS conjugate for maximum power transfer. Clear? So what is the unknown here? Can you tell me what is the unknown? The unknown is the what? Is the Z naught and the what? And the theta. Theta is the what? Is the phase. So look at this equation. Did we see this equation a moment ago? What was it? Let's see. I want you to see this equation. Yes? And I want you to see this equation. What did I do? Zn divided by what? Z naught equal to what? 1 plus what? Gamma L. Zn divided by Z naught. Zn divided by Z naught. So this is equation what? 21, if you are ready. Zn divided by Z naught equal to what? 1 plus gamma L E 2 beta L I designated as what? So what is the beta L? Theta is the same as what? Clear? Okay. Now, this is the same as this one. The same as this one. Yes? Now, for a quarter wavelength transmission line, what is the theta? Theta is what? It's beta L, which means what? What do I have? Zn equal to what? Z naught square divided by what? Z. From this equation, what am I getting? What do I want Zn to be? I want Zn to be the what? Zs conjugate. Are you following me on that? So that you have a what? You have a match. Yes? And instead of using what? And instead of using an LC type circuit, you use a what? A lossless. Just the LC. Did we assume that it's lossless? So is the transmission line. So you get this equation. Z naught equal to what? This. And theta is equal to what? This. How many equations do you have? 2 equations. Why? Because one of them is real, the other one is what? It's a complex part. One more time. You will see something like this in the midterm. What is the unknown? What is the question will give you? He will give you ZL and he will give you what? ZF. And this is the way the question will be asked. Use a transmission line to transform ZL into what? Into ZS or ZS conjugate. Did you get this or not? And what are the unknown? What is the characteristic impedance of the line? And what is the what? What is the length of the line? How long? Remember, theta is what? Beta L. Clear? What else the question needs to give you, by the way? The question needs to give you lambda. Are you following? Or it gives you what? The frequency of operation. Remember, lambda is equal to what? Question? Okay. Clear? Clear this? Yes or no? Okay, what is RS, by the way? RS is the real part of the source. What is XS? The imaginary part of the source. Same thing with the RL. Is it possible that the source is a pure resistance? Then you put the XS equal to what? Equal to 0. It makes things simple. Clear? Make sure these two equations are in your what? In your 8 by 11. Clear? Okay. By the way, I'm not asking you to memorize these equations, but derivation of these equations, straightforward or not straightforward? Straightforward. You follow me or not? Okay, use this equation. Clear? Okay, good.
Professor,
now,
we are out of time.
We are out of time? Okay, you can read this one on your own. Here you can have also what? Multiple transmission line, multiple pieces. Are you following me or not? Yes or no? Okay, some of them are what? Land over 8, some of them are land over 4, and so on, so on. Clear? Can you read this on your own? It's straightforward. Clear? By the way, I will not give you something like this in the midterm, but I will give you something like the previous one. Okay. The lecture on Thursday will not be included. This will be included. Lecture on Thursday will not.
This begins today's session of EE 544 on Tuesday, March 4th, 2014.